Presented here is PlastiVis, a dynamic connectome visualization platform that uses an integrated 3D model and a 2D figure panel to provide insight into how neural monitors and synaptic connectivity are related and evolve over time. Users began with interacting with a 3D model of the brain, which represents the brain's state at a specific time of interest, and can be altered in a variety of ways to present differing levels of detail. By default, the brain is visualized as several regions composed of clusters of points. These points are colored by the regional average of a monitor of interest that the user can select, such as electrical activity or calcium level. Their color scheme is also based on a regional average, rather than an individual distinct neuron value. The size of each point is scaled based on its synaptic activity, defined as the sum of the number of creation and deletions that it is experiencing, with larger points representing highly active neurons and smaller points representing neurons with minimal activity. Between these regions, users can toggle the display of synaptic connections, which are characterized as ingoing or outgoing, and created or deleted, to eliminate the visual clutter of hundreds of thousands of stagnant connections. PlastiVis only shows recently created and deleted synapses, which are blue and red respectively. To perform comparison across different datasets, this 3D model can be generated for multiple simulations at the same time. Another additional comparison tool that we provided is a principal component analysis plot, which compares all the multivariate datasets by performing dimensionality reduction and then plotting the simulations as a colored set of points along the first and second principal components. Simulations that are close to each other on the plot can be interpreted as similar. Furthermore, this PCA plot has an option to exclude the first 50,000 time steps to account for the cold start in some of the simulations. Beyond this PCA plot and a 3D brain visualization are a set of panels that show various 2D graphs. For example, an overview time series plot that shows the average of 5 neural monitors over the duration of the entire simulation, as well as shading around all these lines representing the average to indicate the range of the minimum and maximum. In addition to these 5 neural monitors, we include 2 additional plots summarizing the number of creation and deletion events across the entire simulation. On this overview plot, users can choose which simulations they want to show and hide, as well as zoom in and out from time steps of interest. We also included a vertical line that shows the selected time step that the 3D rendering is created for. By dragging and dropping this vertical line, the 3D rendering will update to show the brain status at the selected time step. Beyond this overview brain time series, PlastiVis also has a neuron and region time series viewer that provides even more detail than the brain time series. These time series plots are updated based off of the user selection on the 3D view and can be customized to show just the monitors of interest. It should also be noted that multiple regions can be visualized at the same time simultaneously. Using this, we observed that non-simulated regions had lower numbers of creation and deletion events in comparison to regions that were simulated, and thus had lower activity overall. Beyond the time series plots, we include a ranking line chart that ranks the regions in terms of each other based off of either relative ranking or absolute changes in creations and deletions. Looking at these line ranking charts, we determined that Area 8 is the most active region, and areas 30 and 34 are very similar in the numbers of creation and deletions they exhibit. However, the 3 simulated regions do generally have more creation and deletion events than the other regions that are not simulated.